Good morning everybody. In the previous lecture, we have solved examples from exercise 5.2 using centroid formulae. Now today we are going to see the proofs of geometrical properties by using vectors from the exercise 5.2. Now here we see some properties. See the first property, prove that the medians of a triangle are concurrent. Prove that the medians of a triangle are concurrent. It means that here we have to prove the three medians passes through a common point. That means the medians of a triangle are concurrent. Okay, we prove this property by using vector. Let capital A, B, C are vertices of a triangle. So means a triangle ABC is given here. This is triangle A, B, C. Let point D, E, F are midpoints of side BC, BAC, AB respectively. It means D is the midpoint of side BC, E is the midpoint of side AC, and F is the midpoint of side AB. So your point D is here. This is point D. Now join AD. So this is midpoint, so the length of these two sides is equal. The point E is midpoint of side AC. So point E is here. So the length of AE and EC are equal. Similarly, the point F is midpoint of EAB. So the point is here, F. So the length of AF and FB is also same because F is the midpoint of segment AB. So as DEF are the midpoints of the sides BC, AC, AB respectively, so therefore AD, BE, CF are medians of triangle ABC. So these three segments are medians of triangle ABC. Let small a bar, B bar, C bar, D bar, E bar, F bar are position vectors of points A, B, C, D, E, F respectively. It means point A bar is the position vector of point A, B bar is the position vector of point B, C bar is the position vector of point C, and so on. So respectively. Now D is the midpoint of segment BC. This point D is midpoint of segment BC. So by using midpoint formula, the position vector of the point D is small d bar is equal to position vector of the point B plus position vector of the point C divided by 2. And we know that position vector of the point B is B bar, position vector of the point C is C bar divided by 2. Similarly, point E, this E is midpoint of AC. So position vector of the point E, that is position vector of the point E is small e bar, and it is equal to A bar plus C bar divided by 2 by using midpoint formula. Also, this F is midpoint of segment AB. So position vector of the point capital F, that is small f bar, is equal to A bar plus B bar divided by 2. That is, now shift this 2 to left hand side, that is 2 into D bar is equal to B bar plus C bar. Similarly here, 2 into E bar is equal to A bar plus C bar, and 2 into F bar is equal to A bar plus B bar. Into D bar is equal to B bar plus C bar. Now in first equation we add vector A on both sides. So we get 2 into vector D plus vector A is equal to A bar plus B bar plus C bar. Similarly in second equation, 2 into vector E. Now in second equation we add B bar on both sides. So we get 2 into E bar plus B bar is equal to A bar plus B bar plus C bar. Now in equation 3, what is equation 3? Twice F bar is equal to A bar plus B bar. Now add vector C on both sides. So we get twice F bar plus C bar is equal to A bar plus B bar plus C bar. Again, that is 2 into D bar plus A bar divided by 2 plus 1 is equal to, here also see, 2 plus 1 means 3. So in each term here it is A bar plus B bar plus C bar divided by 3. Similarly, 2 into E bar plus B bar divided by 2 plus 1 is equal to A bar plus B bar plus C bar divided by 2 plus 1, that is 3. Again it is comma, in third equation 2 into F bar plus C bar divided by 2 plus 1 is equal to A bar plus B bar plus C bar divided by 3. Now see, in all these three equations, their right hand sides are equal, that is A bar plus B bar plus C bar divided by 3. So this can be written as 2 into D bar plus A bar divided by 2 plus 1 is equal to 2 into E bar plus B bar divided by 2 plus 1 is equal to 2 into F bar plus C bar divided by 2 plus 1 is equal to A bar plus B bar plus C bar divided by 3. We consider this is small g bar, say. Now this equation shows that the point with position vector g bar divides the segment AD internally in the ratio 2:1, segment BE internally in the ratio 2:1, and segment CF internally in the ratio 2:1, it means that point G with position vector G bar lies on the three segments AD, BE and CF, and that G bar is same in all the three segments. So A bar plus B bar plus C bar divided by 3. It means that the point G with position vector G bar is common in three medians AD, BE and CF. So this shows that the three medians AD, BE and CF are concurrent. So we have to write here, this shows that the point capital G whose position vector is G bar lies on three medians AD, BE and CF, dividing each of them internally in the ratio 2:1. So therefore the three medians of a triangle, or three medians AD, BE and CF are concurrent. Hence, the medians of a triangle are concurrent. So this is the proof of the geometrical property by using a vector. Prove that the medians of a triangle are concurrent. In board exam, so many times such type of properties are asked in board exam. Prove that the medians of a triangle are concurrent, or prove that the altitudes of a triangle are concurrent, or prove that angle bisectors of a triangle are concurrent. So we see it one by one. This is the first property. Prove that medians of a triangle are concurrent, and we have proved it. So next property, we see property second. Prove that angle bisectors of a triangle are concurrent. Prove that angle bisectors of a triangle are concurrent. The proof of this property: let capital A, B, C are vertices of a triangle. So the triangle is ABC. This is triangle ABC. Let AD, BE, CF are bisectors of angles A, B, C respectively. AD is the angle bisector of angle A, so this is AD, means the measure of these two angles is same, it is AD. Now second angle bisector is BE, so the length of measure of this angle is equal to measure of this angle because it is an angle bisector BE. And CF, the measure of the angle CF is the angle bisector of the angle C. CF is the angle bisector of the angle C. So this is CF. So measure of this angle is equal to measure of this angle because both have same, because it is angle bisector. Let length of BC is equal to x. Length of the segment BC is equal to x. This length is x. Length of AC is equal to y. Length of this segment AC is y. And length of AB is equal to z. Means this length is z. Let small a bar, B bar, C bar, D bar, E bar, F bar are position vectors of points A, B, C, D, E, F respectively. Now observe the figure. AD is the angle bisector of angle A. So point D divides the segment BC. This point D divides the segment BC internally in the ratio AB as to AC. The point D divides segment BC internally in the ratio AB as to AC. The point E, see, now this BE is angle bisector of the angle B. So point E divides the segment AC internally in the ratio AB as to BC. The point E divides segment AC or side AC internally in the ratio AB as to BC. AB as to BC. Similarly, CF is angle bisector of the angle C. So point EF divides the segment AB internally in the ratio AC as to BC. The point F, this point F divides segment AB internally in the ratio F divides the segment AB internally in the ratio AC as to BC. AC as to BC. Now see here 3 points D, E, F with position vectors D bar, E bar and F bar. So bisection formula, small d bar is equal to, see, point D divides the segment, BC internally in the ratio AB as to AC. AB as to AC means here D bar is equal to AB into vector C plus AC into vector B divided by AB plus AC. That is D bar, or here we may write therefore D bar is equal to, see, what is the length of AB? Length of AB is Z and length of AC is Y. So therefore D bar is equal to Z into vector C plus AC, that is Y into vector B divided by Z plus Y. So D bar is equal to Z into vector C plus Y into vector B divided by Z plus Y. Similarly, point E divides the segment AC internally in the ratio AB as to BC. So using section formula, small e bar is equal to, see, point E divides the segment AC internally in the ratio AB as to BC. So here Z into C bar plus X into A bar divided by Z plus X. Also, point EF divides the segment AB internally in the ratio AC as to BC. AC as to BC. So therefore it is F bar is equal to Y into B bar plus X into A bar divided by Y plus X. So here we have the position vectors of the points D, E, F. D bar is equal to Z into C bar plus Y into B bar divided by Z plus Y. E bar is equal to Z into C bar plus X into A bar divided by Z plus X. And F bar is equal to Y into B bar plus X into A bar divided by Y plus X. So from this, here we can write Z plus Y into D bar is equal to Z into C bar plus Y into B bar, comma. In the second equation, Z plus X into E bar is equal to Z into C bar plus X into A bar, and Y plus X into F bar is equal to y into b bar plus x into a bar. That is z plus y into d bar. Now on both sides, in first equation we add x into a bar. Here we add x into a bar. So plus x into a bar is equal to z x into a bar plus y into b bar plus z into c bar. Similarly, in second equation, in this equation we add y into b bar on both sides. So we get z plus x into e bar plus y into b bar is equal to x into a bar plus y into b bar plus z into c bar. Now from third equation, y plus x into f bar. Now in third equation we add z into c bar on both sides plus z into c bar is equal to x into a bar plus y into b bar plus z into c bar. Now in these three equations, the right hand side is equal. See, x into a bar, y into b bar, z into c bar. X into a bar, y into b bar, z into c bar. X into a bar, y into b bar, z into c bar. So this can be written as z plus y into vector d plus x into vector a is equal to z plus x into e bar plus y into b bar is equal to y plus x into f bar plus z into c bar is equal to x into a bar plus y into b bar plus z into c bar. Now 1, 2, 3, 4, these four expressions are equal. It means that if we divide throughout to this expression by a common term, then the value doesn't change. So can I write it as z plus y plus x? That is, we are dividing to this expression by x plus y plus z. So is equal to, here divided by z plus x plus y. See, it is x plus y plus z. So the value doesn't changes. Similarly, in the third expression also, we divide to denominator, means we divide numerator by x plus y plus z, and that is y plus x plus z. Similarly here, at the last term, x plus y plus z. So see here, this is z plus y into vector d plus x into vector a divided by z plus y plus x is equal to second expression is equal to third is equal to fourth. For some time we consider this is small p bar. This is small p bar set. This point is capital P. This shows that the point capital P whose position vector small p bar, whose position vector is small p bar, lies on bisectors AD, BE and CF. Dividing segment AD internally in the ratio z plus y as to x comma dividing segment BE internally in the ratio BE internally in the ratio z plus x as to y and segment CF internally in the ratio CF internally in the ratio y plus x as to z. Y plus x as to z. This shows that the three angle bisectors of a triangle are concurrent. Or you may write, this shows that the angle bisectors AD, BE and CF are concurrent, and hence the angle bisectors of a triangle are concurrent. So in this way we can show the angle bisectors of a triangle are concurrent. So we see next question, question number 3. Question number 3, prove that quadrilateral is a parallelogram if and only if its diagonals bisect each other. So let's see the proof of this property. Let small a bar, b bar, c bar, d bar are position vectors of vertices A, B, C, D respectively of parallelogram. So see here, this property contains if and only if. So the proof of this property contains two parts. One part is only if part and second part is if part. So in first only if part we have to consider the triangle, the quadrilateral is parallelogram, and then we have to prove that diagonals of that quadrilateral means parallelogram bisects each other. And in if part we consider diagonals of a quadrilateral bisects each other, and we will prove that quadrilateral is a parallelogram. So first we see only if part. In only if part we have considered a bar, b bar, c bar, d bar are position vectors of vertices a, b, c, d of parallelogram. So a, b, c, d is a parallelogram. See, this is A, B, C, D. Now its diagonals are AC and BD. AC and BD. And we have to show that the diagonals bisects with each other. Okay. What are the you know that properties of a parallelogram are opposite sides are parallel. Opposite sides of a parallelogram are parallel and equal in length. So here we consider the pair or the side AB is parallel to side DC. Therefore, side AB is parallel to side DC, as well as length of AB is equal to length of DC. What is the property of parallelogram? Opposite sides of a parallelogram are parallel and equal in length. So AB and DC are opposite sides of a parallelogram. They are parallel and equal in length. So AB is equal to DC. It means that the length of the segment AB is equal to length of segment DC. If you observe the figure, the direction of AB is equal to or is same as the direction of DC. Direction of AB and direction of DC are also equal. The length of AB and length of DC are also equal. So therefore, AB bar is equal to DC bar because magnitude and direction both are equal. So these two vectors are equal. AB bar is equal to DC bar. Now by the definition of position vector, see what is AB bar? This is position vector of the point B minus position vector of the point A. Position vector of the point B is B bar. So it is B bar minus A bar is equal to position vector of the point C, that is C bar, minus position vector of the point D, that is D bar. So C bar minus D bar. Again it is equal to, see, this minus D bar can be shifted to left hand side, so it become B bar plus D bar is equal to, this minus A can be shifted to right hand side, so it is with minus sign. When we shift it to right hand side, it become plus, so it is C bar plus A bar. So therefore, B bar plus D bar is equal to C bar plus A bar. Divide throughout to this equation by 2, so we get B bar plus D bar divided, or in the next step we may write one more step that is like this: B bar plus D bar divided by 2 is equal to A bar plus C bar divided by 2. Now this B bar plus D bar divided by 2, this is the position vector of the side BD, and A bar plus C bar divided by 2, this is the position vector of the side or of the diagonal AC. So give this equation number 1. The position vector of diagonal BD is B bar plus D bar divided by 2, and position vector of diagonal AC is A bar plus C bar divided by 2. Therefore, by equation 1, therefore by equation 1, B bar plus D bar divided by 2 is equal to A bar plus C bar divided by 2. It means that by equation 1, position vector of midpoint of the position vector of, see here, midpoint, position vector of midpoint of diagonal BD and the position vector of, I will write this total sentence once again. The position vector of midpoint of diagonal BD is B bar plus D bar divided by 2, and position vector of midpoint of diagonal AC is A bar plus C bar divided by 2. And now by equation 1, the position vector of midpoint of diagonal BD is equal to position vector of midpoint of diagonal AC. So by equation 1, the position vector of midpoints of diagonals BD and AC are equal. Therefore, the position vector of diagonal BD and AC are same. Now, the position vectors of the diagonal AC and BD are same. It means that the diagonal AC and diagonal BD bisects each other. The position vector of midpoint of diagonal BD and AC are same. This shows that the diagonal BD and AC bisects each other. So see here, we have shown if quadrilateral is a parallelogram, then the diagonals of that parallelogram bisects each other. Now in converse part, we have to show that if the diagonals of a parallelogram or diagonals of a quadrilateral bisects each other, then that quadrilateral is a parallelogram. We prove its converse part. See, conversely, suppose that the diagonals of a quadrilateral bisects each other. So that is, here diagonals of this quadrilateral, suppose BD and AC, that is the diagonals BD and AC bisects each other. Therefore, the midpoint of diagonal BD and midpoint of diagonal EAC are equal. Now, the midpoint of diagonal BD is B bar plus D bar divided by 2, and it is equal to midpoint of diagonal AC. So therefore, it is A bar plus C bar divided by 2. See, we have considered the midpoint, the diagonals of a quadrilateral, that is BD and AC bisects each other. So therefore, the midpoint of diagonal BD and midpoint of diagonal AC are equal. It means that the position vectors of the midpoints of diagonal AC and diagonal BD are equal. And what are the position vectors of the midpoint of diagonal BD? That is B bar plus D bar divided by 2. The position vector of the midpoint of diagonal AC, that is A bar plus C bar divided by 2 by using midpoint formula. So now throughout to this equation multiply by 2, multiply throughout to this equation by 2, so we get B bar plus D bar is equal to A bar plus C bar. So shift this A bar to left hand side, so it is B bar minus A bar is equal to, shift this D bar to right hand side, C bar, A minus, this minus D bar. So B bar minus A bar is equal to C bar minus D bar. By using the definition of position vector of the point, what this B bar minus A bar indicates? This is AB bar. B bar minus A bar means capital AB bar is equal to C bar minus D bar, that is capital DC bar. So AB bar is equal to DC bar means the vector AB is equal to vector DC. This shows that AB bar is parallel to DC bar, and magnitude of vector AB is equal to magnitude of vector DC. So therefore, now vector AB is parallel to vector DC means side AB is parallel to side DC. Therefore, side AB is parallel to side DC. Now, magnitude of vector AB is equal to magnitude of vector DC. We know that magnitude of vector is nothing but the length of that segment along which that vector lies. So AB bar is the vector along the side AB. So length of side AB is the magnitude of vector AB, and length of side DC is the magnitude of vector DC. So therefore, and AB is equal to DC. So from this, AB is parallel to DC means opposite sides are parallel and they are equal in length. This shows that the quadrilateral ABCD, this shows that quadrilateral ABCD is a parallelogram. And at the last, write hence quadrilateral is a parallelogram if and only if its diagonals bisect each other. This is the proof of the property. So today we stop it here.